Welcome back to another tutorial. Today we're going to be looking at how to make a character move on a tilemap grid using the AStarGrid2D functionalities, and also how we can utilize custom data layers in tilemaps to determine where a player should be able to move and how to alter the A-star pathfinding based on the settings. So let's get started. Alright, so all I've done is create a new 2D scene, set it as the main scene, and I've also imported the tile map that we're going to be using. I'll provide a link in the description. And before we start, since we work with pixel art, we're going to have to change a couple of things. Let's set the window size first, like so. And then set the stretch mode to canvas items, and then under rendering we also need to change the default texture filter to nearest to get clean pixel art. Okay. Now that we've done that, we can start making the tile map. Create a new tile set, drag in your tile map. Yes, we want to cut them up. And then you can, let's draw a quick tile map. So go to tile map, click a tile. And let's add some trees. Okay, that's it for the tile map. Then we're going to add a new node 2D, which is going to be the player. And he's going to need a sprite, and he's also going to need a camera 2D. And for the sprite, we're going to use a new atlas texture. And we actually have to drag it in. Edit the region. We're working with a tile set that's 16 by 16 pixels. Pick this guy. Okay, let's move this node 2D into the middle of a tile map cell. So let's see, is this the middle? One down. There we go. So now it's in the middle of the tile map. That's good. Okay, then we can start adding a script. And we're going to be doing a couple of things in here. We're going to have to listen to input. We're going to have to initialize the AStarGrid2D object. And we're going to have to move the player once there's a path available. So let's start with the initialization of the AStarGrid. It's going to be an AStarGrid2D object. And we're doing this so that we have a reference to the grid that we set in all of our functions. We won't be using process, and in the ready function we're going to create an instance of this object. New. Okay, and in order to align our AStarGrid2D with our tile map, we need to set the region of the grid equal to the use rectangle of our tile map in order to make our cells align, so both the tile map cells and the AStarGrid2D cells. And we can do that by getting a reference to our tile map, and then we're going to say AStarGrid.region. We're going to set this to tilemap.getUsedRect. We're also going to set the cell size, which is going to be a vector2 that contains a 16 by 16 because our tile map is 16 by 16 pixels. We're going to set the diagonal mode, which means that the A-star pathfinding algorithm will be able to find diagonal moves. We don't want that. We only want the player to move left or right or up or down. And we can do that by setting diagonal mode to never. Like so. So we've changed a couple of things on the AStarGrid2D object, and especially for the region and the cell size, we need to call the update function on this object in order for it to be processed. Okay, so that's our grid. Then next up, we're gonna make the function for listening to the input. And we get the event in this function. So let's also make an action called move, and we're gonna bind it to the left mouse button. So if event.isActionPressed move is false, then we don't want to do anything. But if it is the move, so if we click, then we're going to get into this function. And what do we want to do in this function? In this function, we want to get the path towards the mouse point clicked. And we can do that by saying var id path, which is going to be the result of this function call on the grid. get ID path, which will return a array of vector2i's, which correspond to tiles on the tile map, as well as tiles on the actual AStarGrid2D. You should basically see the AStarGrid like a separate tile map over your existing tile map, but it only stores the coordinates and it serves as for navigation purposes only. And what we're going to do is when the player clicks somewhere, we're going to translate the global position to a vector2i and then let the AStarGrid determine how it needs to walk there. And when we want to get a path, it takes two parameters. It takes a from ID and a to ID. So we need to get two vector2i's, the position where we want to navigate from and where we want to go toward. Well, we want to navigate from the position that we are, so we can translate our global position to a vector2i using the tile map. So we're going to say tile map local to map, which means we're going to convert a vector2 global position to a vector2i. See, this function requires a vector2, so that's going to be global position of the player object. And then the second variable is going to be the to vector2i. So we're going to have to translate the global mouse position when you click to a vector2i, and we can do that by saying tile map local to map, and then we can say get global mouse position. Yeah. All right, let's see what it returns. So when I click below our character, we get the current position and the position that we want to go to. If I click on the character, we get only our current position. And the farther I click, the more nodes we get because the path is going to be longer. Well, we don't want to get the first position. We only care about the positions that we want to go to. So in order to do that, we're going to slice this result, which will remove the first item in the array. So when I click next to us, we only get the position that we want to go toward. That's good. All right, so we have our path. Now to actually start moving, we're going to have to set another variable because we're going to be moving in our physics process function. And we're going to call this current ID path. And it's going to be an array of vector2i's because that's what this function returns. So if ID path is empty, is false, because if we click on ourselves, we have nowhere to go, so we don't want to set this to an empty array. We're gonna, if it's not empty, our current ID path is ID path. Right, so now we have our path stored in this variable. Then let's start moving by setting up the physics process function. And this physics process function is going to be called every physics frame, but we don't want to do anything if there's no path set. So if our current ID path is empty, return. If it's not empty, however, we want to start moving. And we're going to have to move our player to a vector2 position because we can't move our player to a vector2i position. So first of all, we're going to set a target position variable. And that's going to be equal to the first item in our current ID path, but we have to convert it to a vector2. And the tile map actually has a function for that, map to local. And we can pass in the first item of our current ID path by saying current ID path dot front returns the first item. Now we have a position we want to move to. Let's move our players. So global position is global position dot move toward, and we want to move toward our target position, and then also a speed. So let's say 1. Okay, we should already be moving 1 tile now if we click somewhere. Yeah, so it moves 1 tile, but we want to loop over all the points in our vector2i array and then keep on moving because we have all the positions stored in our little array over here. So we move to our next position, and then after we've done that, we want to check if we've arrived at the set position, which is the first item of our current ID path. So if global position is the same as target position, then we want to pop the front of the array of paths because we want to continue to the next item in that array. I think we can say pop front. Yeah, so pop front will remove the first item of the array, which means the next iteration target position will be something else. Yeah, so you can see we're already moving on the grid toward our target position. And as you can see, we can move over obstacles. That's not really what we want. And if you spam click, you can even see that we can kind of glide around because we're not making sure that when you're moving, the next move should be from the next target position, and we don't do that right now. So let's see how we can fix being able to move over obstacles and how we can also fix getting off the grid. All right, so how are we going to determine if a player should be able to walk over a certain tile or not? And we're actually going to do that by adjusting our AStarGrid2D object or telling it which tiles are going to be solid. And solid means that it won't be using the cell for calculating the navigation that needs to take place. And we're going to do that using a custom data layer. So go to your tile map, go to your tile set, add a custom data layer. Let's call it walkable. It's going to be a Boolean because we're going to assign a value to separate tiles in your tile map. Go to your tile set, go to paint, and select the walkable custom data layer. And now we're going to tell this tile set that these 4 tiles, we only use this one, but these 4 tiles will have this value set to true. And we can use it in the script to tell the AStarGrid, okay, we're going to be looping over all the tiles, and if this value is false, then disable this cell for navigation. So we've set this data. Now we can actually go to the script, and we're going to start by looping over every cell in the tile map. And we can do that by taking a look at this value. This function will actually return us the position, the initial position. So this is the topmost left point of the tile map and also the size in tiles. And we're going to be looping over these 2 values in order to loop over all the available tiles. And we can do that by saying for x in tilemap.getUseRect dot size dot x. That was actually what the s was for. You can see that in here. Rect2i has 2, well, actually 3, but 2 properties that we're going to use: position and size. And we're right now going to loop over the size of the rectangle of the tile map. So we're going to do this for the x-axis. We're also going to do this for the y value. So now we should be looping over every single tile that is available within our rectangle. And we're going to be converting these 2 values to a vector2y because we want to know the tile position. Vector2i, and then we can just say x value and y value. This is not correct, but we're going to run into what's going to happen soon, so maybe I can explain it a little easier. So now that we have the tile position, we want to get the walkable tile data, right? So we're going to say tile data. First we have to get the tile data object. Get data or something, get cell tilde. Yeah. Layer 0, we didn't change anything, and then the tile position. We want to get the tile data for this tile. And if tile data is null, which means there's no tile there, or if tile data dot get custom, what is it? Get custom data, and it's going to be our walkable data. If we're not allowed to walk on this because it's false, then we're going to tell the AStarGrid that it needs to set this cell to solid. So we're going to say AStarGrid.setPointSolid, and it needs a position. So that's going to be the tile position, and it needs to be set to true, but that's the default value. So now this position in the tile map on the AStarGrid is going to be disabled for navigation. And I think the best way we can check this is just by going in. And you can see it's not working. And why isn't it working? Well, that's because these values, these x and y values, are not relative to the offset of the tile set. So in the first iteration of these both loops, x is going to be 0 and y is going to be 0. And that will translate to this tile. And that's not what we want. We want to start on the topmost left tile and then scan every tile. Right now it's doing it from the wrong offset. And in order to do that, we need to go into here and we want to offset this by the second value in this function. And that's going to be position dot x. And we're going to do the same for y. And these could be minus values, these could be positive values, as long as they get applied to the correct position. Now we can actually get the correct tile. Right, and we shouldn't be seeing any errors now. And if I click somewhere, it will now actively dodge the trees because their walkable value is set to false. So when I click now, he will find a way around the cell that has been disabled. And if we go to the edge of the map, we've also covered these cells because they don't have data. So when I click here, nothing happens, but they are inside of our AStar grid, but they're just disabled. So we will also dodge them. So in that way, you don't have to have perfectly square tile maps, because if there's no tile data available, we will just disable it in the AStar grid. And now there's still the issue of spam clicking and then going off the grid because we don't set the correct path from the next target position. So let's take a look on how we can fix that. In order to fix the fact that we can still slide around, we need to make sure that we only set the target position directly if we're standing still. And then we also have to make sure that once we arrive at our destination, that we set the target position if we see that the array that we've adjusted is not empty. And apart from that, we also need to calculate a path from the target position if you're moving, because if you're moving already and you click somewhere else, we want to update this variable with a path that is calculated from the position you're going to be arriving at, so that we can immediately continue moving. So how do we do that? We first start off by making the target position available to the entire script. And then we're also going to use a flag for determining if we're moving, yes or no. Okay, let's start in the physics process. So if is moving is false, then we want to set the target position, because if we are moving, we don't want to do this. And now in order to determine if we're moving, we're going to say is moving is true over here, because we weren't moving, but now we are. And then beneath the fact that we check, like we changed the current ID path variable once we reach our position because we pop it. Now we also have to select the next value and put it in the target position, because right now we move one tile, we stop, because we don't do this anymore. We don't do this every frame. We used to, but now we do it only when we're not moving. So in here we're going to check if the current ID path is empty. And if that's false, then we're going to be saying current target position is current ID path. Well, we actually have to convert this because this is we need to convert it to a vector 2. So we can use the tile map for that. Map to local. And then we pick the first item. Was it first, front? Front. So now when we have arrived, we see it's not empty. Okay, let's go to the next tile. It's basically a loop. But if it is empty, then we're done moving. So moving is going to be false. Okay. Now in order to determine which or where to start our path generation from, we need to check if we're moving when we're going to get a new ID path. So let's make this variable like so. And then we're going to check if we're moving. If we're moving, we actually don't want to do this from our global position, we want to make a new path from the target position. And we don't want to slice that because otherwise we're still going to be able to move diagonally. And otherwise, it's just going to be what we already had. So it's going to be calculate a path from a global position. So if we're moving, our starting point will be our destination. And if we're not moving, we use our current position as the starting point. Otherwise, it's going to be the target position. And this should be it. Yeah, so now I can spam click. You can see that it has to finish moving to its target before it actually gets the newly set target position, which is coming from the array that we overwrite, basically. Yeah, so now we have both the tile map data and the fact that we wait for the navigation to finish before we actually use our new path. And for a bonus, let's look into how we can draw a line in order to visualize where we are going. In order for us to start drawing a line to where we're moving, we're going to need another resource that is being provided by the AStarGrid. And that's going to be a point path, which is basically an array of vector 2s. Actually, it's a packed vector 2 array. And we're going to pass it into another script, which will draw the line for us based on the positions of the vector 2s in this array. And in order to fill this array, we're going to, in the input function, when we determine that the path is not empty, we're going to set this variable, current point path. Path is AStarGrid.getPointPath. And it needs two vector 2i's again. So let's just pass in the target position and the mouse position again, because we still need these values. So now we've set this value. We're going to create a new node, which is going to be responsible for drawing the line. Let's call this path. Add a script. And all that we're going to do in here is we're going to make a function draw. We're going to need a reference to the player, because if there's no point path, we don't really care. If player.point current point path is, if it's empty, return. If it's not empty, we're going to draw a, was it polyline? Yeah. This function actually wants a packed vector 2 array, which is what this is. So we can pass it in. And then it also wants a color. Well, let's do a color.red. It wants a color to draw the line. And in order for this function to be called, we need to call another function in the process of this script, which is called queryDraw. Now this will be updated every frame. So if this value changes, then the correct line is also drawn. Okay, let's check it out. So you can see that the offset of the line is now, the position is now in the top left of the tile that we're moving on. So we might have to add some offset, and we can do that by adjusting the values in our current point path by going to the player, and after we've actually set this value, we're just going to loop over it. So for I in current point path.size, we're gonna set the value we're currently looping over to a value plus half of the size of our tile set. So plus vector 2. We use 16 by 16, so 8 and 8. And so now it should be centered in our tile. And it is. So now you can see the path that we're gonna move, that the AStarGrid determines you should move. You can see if we click rapidly, it changes path, but we still have to wait until we're done moving. So I think that's it. I hope you learned something. This might be a bit of a heavy topic, but I hope it was all clear. Thanks for watching, and let me know what you want to see next.